Hello friends, in this video today we're going to discuss about reduction of two body problem under central force to one body problem. So let's start. Suppose we have a system of two particles of mass m1 and m2. Suppose mass m1 and another is suppose mass m2, and their position vectors suppose r1 and r2 be their respective positions vectors. So here O is the origin, masses m1 and m2 and their positions vectors be respectively r1 and r2. Now relative distance between these two masses m1 and m2 be suppose r. This is suppose r. So now you consider this vector in this direction. This is suppose r. Then what will happen according to the triangular law of addition, vector addition, then this r2 will be the resultant, isn't it? So r, then we will get r vector plus r1 vector will be vector r2, and that implies r is equal to r2 vector minus r1 vector. And if you consider the direction of this r vector in this way, then you will get r vector is equal to r1 minus r2. So you can consider this one as well as this one. So in both cases we will get the same required equation that we are going to find in this case. So in this case actually what we are going to do, this is a system of two particles, so we have to convert this system, we have to treat this system as a single particle. Okay, so we will find an equation for this system. We will reduce the system to a system of one body particle or single particle. Okay, so let me show you how. So now here you can see, let me clean this part. So r, that's equal to, let me write r2 vector minus r1 vector. So here you see this point here, you can say this point be the center of mass. Let us assume this point be our center of mass, cm, center of mass, and its position vector it be suppose capital R, represented by capital R. So r dash be the position vector of the center of mass. In this case, so now you see this potential energy of the system, suppose B, and V must be the function of R, because you know potential energy is depends on position, so that's why it must be a function of R. That's why VR be the potential energy of the system. Okay, now we know the Lagrangian, L is given by kinetic energy minus potential energy. We know this relation, L is equal to kinetic energy minus potential energy. So what will be the kinetic energy of this system? So as we have two particles here, m1 and m2, so what will be the kinetic energy of these two? Now kinetic energy of this first particle m1, so its kinetic energy of this particle will be given by half m and the square of its velocity. Velocity will be given by rate of change of its position, that is r1 dot. So and it's square. This is the kinetic energy of this m1, and what will be the kinetic energy of this particle m2? So that's going to be equal to half, sorry, here it should be m1, now here it is half m2 r2 dot square. So this is the kinetic energy of this m2, this particle. So total kinetic energy will be sum of these two. So this is L is equal to, now potential energy of the system is V of R. So this is equal to L. Now let us suppose this is equation number 1. Let us suppose this is equation number 1. Now using the ratio of vector formula, here you see the ratio of vector using, so where we had taken the CM, that means center of, here you see this is the center of mass. Suppose if you see here, this is center of mass, isn't it? So center of mass. So according to ratio formula of vector, this R will be given by this position vector of this center of mass capital R, that will be given by this is equal to m1 r1 vector plus m2 r2 vector by m1 plus m2. This is suppose equation number 3. Sorry, not 3, 2. Equation number suppose 2. So we have already got that r vector r, that is position distance between this m1 and m2, that is equal to r2 vector minus r1 vector. So from here, so let me write here cleanly. Now r vector is equal to r2 vector minus r1 vector. So from here what we can write, that r plus r1 vector is equal to r2 vector. So this is r2 here, okay, it's supposed to be r2. So now we replace this r2 by this value of r2. So we are going to replace this r2 by this. So then this equation number 2 becomes r vector is equal to m1 r1 vector plus m2. Instead of r2 we are going to write r vector plus r1 vector by m1 plus m2. Now if you simplify this equation, and from here we can find r1. So what we are going to find from here, r1 we are going to find. So in order to simplify this, what we should do, we have to multiply these two first, then we will take commons, what are the terms will be common, then doing all those things. So let me show you one thing first. So it will be m1 r1 vector plus m2 r vector plus m2 r1 vector divided by m1 plus m2. Now here from these two you can take r1, take r1 common. Okay, on taking r1 common, what you will get within bracket m1 plus m2 plus m2 plus m2 into r vector by m1 plus m2. So this can be written as r1 by r1 plus m2 r by m1 plus m2. Okay, so this is r vector. So from here r1 will be equal to, vector r1 is equal to capital R vector minus m2 r by m1 plus m2. So hope you have got this. This is suppose equation number 3. This is suppose equation number 3. So in order to find r2, what will be r2? So in that case what we are going to do, so again from this relation r vector is equal to r2 minus r1 vector, from here what we can find, r1 is equal to r2 vector minus r vector. So we are going to use this result in equation number 2. Here we are going to use the value of r1 in equation number 2. Then using this value in equation number 2, what you are going to get, so we get r vector is equal to m1 into r2 vector minus r vector plus m2 r2 vector by m1 plus m2. And from here, if you simplify this, you will find r2 vector is equal to r vector plus m1 vector r by m1 plus m2. If you simplify this, you will get this one. Okay, so now this is suppose equation number 4. This is suppose equation number 4. So now what we are going to do from these two equations, if you differentiate these two equations, if you differentiate them with respect to t on both sides of these two equations from 3 and 4, okay, so then what will happen? From equation number 3 we can find r1 dot. So here dot represents d by dt of r, that is nothing but r dot. So hope you have understood this. So if we find the derivative with respect to t of this equation number 3, then what we will get? Then we will get, so let me scroll down, then we will get from equation number 3 we will get r1 dot vector is equal to capital R dot vector minus m2 r dot by m1 plus m2. So this is equation, I will give the equation number later. Then from this equation number 4, if you find the derivative with respect to t, then from equation number 4 you will get r2 vector dot r vector dot derivative of r, that means, so here m1, so this is supposed to be plus m1 r dot vector by m1 plus m2, and this pair of equations let us consider as equation number 5. So hope you have understood till this. So now what we are going to do, we are going to use these two values of r dot 1 vector, r2 dot vector in equation number 1, in this equation. Here we are going to put the value of r1 dot vector and here r2 dot vector. If you put these two values from equation number 5 in 1, so using, so what we are going to write, using equation number 5 in 1, if you use these two values in equation number 1 in this equation, let me show you again here. So replace this r1 dot vector, r2 dot vector by these two values of r1 dot vector and r2 dot vector. Then so we get, using 5 in 1, Lagrangian L half m1 r vector dot minus m2 r dot vector by m1 plus m2 whole square, then plus half m2, then capital R dot vector plus m1 r dot vector by m1 plus m2 whole square minus potential difference, potential energy Vr. Okay, so that's what we have got. So apply here a minus b whole square formula, and here also a plus b whole square formula. Then what we will get, half m1, and within bracket we will get r vector whole square minus twice r dot vector, not r vector, this is r dot vector, then m2 r dot vector by m1 plus m2 plus m2 r dot vector by m1 plus m2 whole square curly bracket closed, and from this what we will get plus half m2 within curly bracket capital R dot vector square minus, sorry, not minus, plus twice AB. A is here, R vector dot or R dot vector, same thing, M1 R dot vector by M1 plus M2, then plus M1 R dot vector by M1 plus M2 whole square, then bracket closed again, minus VR. That's what we have got. Now let's multiply this term with this, and so this term with this. So then what you will get? So let me show you. So multiplying after simplification, you will get half m1 r dot vector square and minus, if you multiply with this one, 2 will be cancelled here, then m1 r dot m2 r dot vector, here vector sign, by m1 plus m2 we will get, then plus half m1 m2 r dot vector by m1 plus m2 whole square. Then from the remaining part we will get plus half m2 r dot vector square plus, and if you multiply this one with this, what we will get, 2 will be cancelled, so m2 r dot vector m1 r dot vector by m1 plus m2 plus half m2, when you multiply this term with this, you get half m2 m1 r dot vector by m1 plus m2 whole square, then at the end minus v of r. Okay, so here you can see we can cancel these two terms. Okay, is that clear? And from here we can take r dot square common, half m1 plus m2, so let's take capital R dot vector square, that's common. Then from the remaining two terms, here you can see from these two what we can take common. So from here we can take half m1 plus m2, then one more thing, wait, into m1 m2 r dot square by m1 plus m2 whole square. So here this part is taken common, and within bracket we have left out m1 plus m2. So here you see, so from where we have got this, from these two terms, from these two terms we have taken this part common. So hope you have understood this. So it is very simple simplification. Now here you see this is square, so it will be cancelled with this term. So here one more thing, minus br. So here you can say this was for the above equation, so let me write here, this minus br was for the above equation. Okay, so L is equal to, we have got half m1 plus m2 r vector dot square plus half m1 m2 by m1 plus m2 small r dot vector whole square minus vr. So we have got this result. Now let us take this one as capital M, and this one will be nothing but reduced mass, m1 m2 by m1 plus m2. This one will be called reduced mass. So let us take this one as mu and this one as capital M. So here then we can write the equation as L capital M capital R dot vector square plus half, and reduced mass is suppose mu. This is small r dot vector square minus potential energy Vr. So here capital M is equal to m1 plus m2. This is capital M, and the mu is nothing but m1 m2 by m1 plus m2. So hope you have understood this. So this is suppose equation number 6. This is our equation number 6. So hope you have understood. Now let us apply Lagrange equation of motion. So Lagrange equation in terms of capital R dot, or you can write in terms of capital R and small r, we can get two equations. One is given by d by dt of del L by del capital R dot minus del L by del R is equal to 0, and another equation will be given by, so let me take this one as equation number 7, and another equation d by dt of del L by del small r dot minus del L by del small r is equal to 0. This is nothing but Lagrange equation. This is equation number suppose 8. Now from here you can see, if you find del L by del r, then here you see this is the only function, sorry, not del L by del r, del capital R dot. This is the R dot, this is the only function of R dot, and remaining terms will be 0. Then if you find the derivative of this in this case, then you will get half capital M 2 R dot, and these two cancel, you will get M R dot. Okay, so what we will get here, d by dt of M R dot factor minus, here you see, so if you find this from this equation number 6, then what you will get, so capital R, there is no function which is there is no any function of capital R, so that's why this term del L by del capital R will be equal to 0. If you put 0 here, then we will get this one is equal to 0. And then if here you can see the derivative of this term is equal to 0, what does it mean? It means M R dot is equal to nothing but, it is constant, not 0, it is constant, because its derivative is 0, that's why it must be constant. And we know that mass is always constant, so therefore the result to be constant, this R dot must be also constant. R dot means velocity, that means we can say the center of motion, center of mass is moving with the constant velocity, that is R dot vector, this is constant. That means this velocity, the constant, center of mass is moving, so center of mass is moving with constant velocity. Now here you can see, let's go to the other equation, this equation. Now you can see, So from this equation number 6, if you find del L by del small r dot, so here this is the function, only function of small r dot. So then here you see, if you find the derivative of this, then you will get this gonna be 0 and this gonna be 0 if you differentiate with respect to small r dot. And from here what you will get, mu twice small r vector. So this to cancel, you will get mu r dot vector. So from this equation here we will get d by dt of mu r dot vector, and here you see minus. Now let's find del L by del R. What will be del L by del R? So in this case, let me clean this. Here you see, so del L by del R. So here this is function of R, so that's why del L by del R will be given by del V by del R, where V is function of R. So that's why we can write from equation number 8, we have got del V by del R is equal to 0. So d by dt, mu is the reduced mass here, and r dot vector is equal to V by R. So here one more thing, so in this case what to do, here you see this is negative sign, so it will be negative. So if you put negative here, so this sign will be positive. So if you put here minus del V by del R, then it will be positive, and on the other side it will be minus del V by del R. So if you find the time derivative of this r dot, then it will be r double dot mu r double dot vector minus v del V by del R, and this is function of R. This is function of R. So here you can see, so this is the equation of the system we have considered. Okay, so we can say this is the equation of the system under consideration. And this is our required equation, so which is function of R only. Now again here you see, as we have got that this r dot vector is constant, that means the center of mass is moving with velocity, constant velocity. That means the motion of, now in this system, now let me go to the diagram here. In this system you can see, in this system, and motion of this system of these two particles doesn't affect on this center of mass. That means the motion of center of mass is not affected by the system of these two particles, as it is moving with constant velocity. That's why this equation, so this equation number 6, here you can see we have got this equation number 6. This equation number 6 can be reduced to, so in this case, as the center of mass is not affected by the motion of the system of particles, it is moving, center of mass is moving with constant velocity. Okay, it is moving with constant velocity, so it is not affected by the system of particle, motion of system of particles. So we can ignore this term from this equation. So that's why this Lagrangian L will be equal to, therefore equation 6 reduced to L half mu r dot square minus v of function r. So this equation number 6 is reduced to this equation, So this is the equation number 6. We have ignored this term as the center of mass is moving with constant velocity, which is not affected by the system motion of the system of particles. So that's why it can be reduced to this form. So here you can see this is what, if you observe the equation, it seems to be the equation of a particle of mass mu. Okay, this equation of a single particle of mass m, sorry, not mass m, mass mu, moving with velocity r, small r dot. So hope you have understood this. That's how we can reduce a two body problem to single body problem under central force. So hope you have understood this. If you like this video, please hit the thumbs up button, and if you are new to my channel, subscribe the channel and share with your friends. Help me to grow the channel. Thank you for watching.